So cell membranes are actually just a great study in the use of solubility. So if you've had your bio courses already, you know that cell membranes are made up of a lipid bilayer. It's often drawn like this, with a head on the outside, tails towards the middle, more tails on this side, and then a head on the inside. So over here would be outside the cell, and this would be inside the cell. I'm not going to draw all the tails, but you could have here all the way around. So this is your inside the cell area. Now, how does solubility enter into this equation? The structure of a common phospholipid that you'll see in a cell membrane. Here's where we have what we call the head, the sort of circular part. And you'll notice that there are charges here. There's charges and there's a lot of polar bonds. Phosphorus-oxygen bonds are polar, oxygen-carbon bonds are polar, nitrogen-carbon bonds are polar. So this part is very polar, while at the other end, we have these two long straight chain hydrocarbons that are very nonpolar. So we have our polar head and our nonpolar tail. So what happens when something tries to come in and out of your cell membrane, if whatever it is polar, it gets attracted to the head, but it can't pass by the tail because there's no affinity for your polar molecule with the tail parts. So your polar molecule comes here and gets stopped because it can't make it through. Now your nonpolar molecule comes here and is pushed away from the polar head. So nonpolar things can't get through. So polar things can't get through because they're repelled by the nonpolar tails, and nonpolar things can't get through because they're repelled by the polar head. So in effect, cells can very carefully control what gets in and out of the cell, and of course there are channels and other things that you can learn about how cells let things in and out of the cell when they want to. Section 3.9 relates functional groups to reactivity. There are several really important concepts to understand coming out of this chapter that you'll carry with through the rest of organic chemistry. The first one is that functional groups create reactive sites on the molecule. The second one is that electron-rich sites will react with electron-poor sites. And the third one is that nucleophiles will react with electrophiles. And that gets to another common question that I will ask all the time when we're looking at reactions. And the way that I ask it most of the time is, who has electrons? And who wants electrons? So a nucleophile is who has electrons in a reaction, while the electrophile is who wants electrons in a reaction. So for example, you could do some reactions where you have a pi bond reacts with something that's an electrophile. What we talked about before, pi bonds are extra electrons, and they react like nucleophiles. So that's who has electrons. The electrophile is who wants electrons. So that forms a new bond. Or another example that we'll see fairly soon as well is that we could have an alkyl halide and react that with some kind of a nucleophile. The nucleophile has electrons. There's a delta plus on this carbon and a delta minus on this chlorine. So this carbon is who wants them. So the nucleophile goes from there to the carbon, but it pushes off the chlorine in the process. We'll see a lot more about that reaction starting in Chapter 7.